guys, this is a question from the UVA, and the question is cutting sticks. It states that we have to cut the wood stick into pieces, okay? And the most affordable company, the Analog Cutting Machinery Incorporated, ACM, charges money according to the length of stick being cut, okay? Their procedure of work requires that they only make one cut at a time, okay? It is easy to notice that different selection in order of cutting can lead to different prices. For example, consider a stick of length 10 meter that has to be cut at 2, 4, and 7 meter from one end. Basically, can we say that it is a coordinate given that in which we are performing a cut? Like uh, let's say this is the our stick, right? This is our stick of 10 meter. So from here it starts one end and here it ends. So basically from one end I'm cutting at 2, 4, and 7 length. So basically I can map that. Can I cut at the coordinate 2? Then I cut at the coordinate 4, and then I cut at coordinate 7. Yeah. Basically we are given with the coordinate at which the cuts are performed. Right? Yeah. Now let's read more. There are several choices. Yeah, we can have several choices, and one can be cutting first at 2, then at 4, then at 7, and this leads the price of 10 plus 8 plus 6, that is equal to 24. Okay, because the first stick is of 10 meter, the resulting is of 8, and the last one is of 6. So what it verifies that I'm given that the charges of money will be according to the length of stick being cut. So here the first is of 10 meter, so I get charge of 10. So basically the cost of cutting will be your current length. Yeah, that's what it tells also. Like it charges money according to the length of stick being cut. So the moment whatever the length is there before the cut is performed, that will be the cost to cut the stick. Okay. Yeah. Now the first stick is of 10 meter. Yeah, that's what it say, and the resulting is of 8. Yeah. And now it cut at coordinate 4. So it already cut from 0 to 2 coordinate, right? Now it cut from coordinate 2 to 4. That's why last one is of 6. Like only 4 length get reduced, right? Yeah. That is generic. And that's why we get something like another choice could also be possible. You cut first at 4, then 2, and then 7. Fine. This will lead to similarly 10, 4, 6, 20, which is a better point, right? So what I want to find out minimum cost of cutting a given stick. So basically I am given with the coordinate at which the cut is performed. Now I have to check, or basically I have to found a variation such that we perform the cut in an order such that I will get the minimum cost of cutting. Basically by performing a cut at the like all the coordinates were given. Okay. Yeah. And what is the input format here? The input will consist of several input cases. The first line of test case will contain a positive number L that represent the length of stick being cut. Okay. And we can assume that L is less than or equal to 10 is to the power 3. And the next line will contain the number n, that is n is less than or equal to 50 of cuts to be made. The next line consists of n positive integers, ci, basically the coordinate that lies between 0 to L. I cannot perform the cut at the ends because the length of stick will remain same. Like if you're cutting at the end, it does not mean it's not a valid cut. So that's why ci is given as 0 to L, because I should always perform the cut at the, what do you call guys? I should always perform the cut in the middle, not at the ends, right? Yeah, of the stick, right? So that I can divide the stick into 2 parts, right? So one thing I get that from this also, that the segment, whenever we look for a segment of stick, it is made up of 2 coordinates, like segment A, or basically can we say that this is the K1 and K2. So if I am cutting, let's say this is a stick, something like this, and I'm cutting the segment out from it. So you can see that it is made up of 2 coordinates. So to form a segment, I need two coordinates. Basically, in the stick, basically we're cutting a stick, we always cut a segment, right? Segment is our one of the element. Can we say that? Yeah. So we can say that to form a segment, I need two coordinates. So two coordinates will lead to formation of one segment. That is the first thing, or another thing we should keep in notice, right? Yeah. That is another part of it. Now the question tells that basically where we are. Yeah, so we can assume L is lesser than 100,000, 10 to the power 3. And next line will be the number of cuts we may have to make, right? And the next line is the coordinates that we already talked, representing the places where the cuts have to be done. It is given in strictly increasing order, okay? And input case with L equal to 0 will represent the end of input. So look at this, guys. This is a bit trickier here. In general, in CF, we are given the number of test cases, but here we are not. The moment, like in the one test case, we are given with the length of the stick that I need to perform the cut, the number of cuts, and the coordinates we are performing the cut. Same goes for another test case, but the moment the L becomes 0, our test case get ended. So that's what we need to take care of. And the output, we have to print the cost of optimal solution of cutting problem, that is minimum cost of cutting the given stick, and we need to format it like this. Minimum cutting cost is the whatever the optimal cost we get, that I need to format it. Okay, yeah. Now let's come to the solution part of it. Before that, let's come to the logic part of it. Okay, yeah. So what we given off with here, right? We are given with the length of string, right? Yeah, L is the length of stick, and we are given with the coordinate. Basically, uh, if I say that sample input, in general, we are given length of stick is usually known only. So sample input is a 1D array that is representing the coordinate at which the cut would be made, right? Now, if I look for here, the value of this n, the length of this array is lesser than equal to 50. Fine. If I look more here, then I need to find here the minimum cost to perform all cuts in the over this length of stick. So can we say that I need to perform the minimum cost over the length of stick? Basically, the range of it should be 0 to L. Yeah, 0 to L will be safer range, in which I can say that the one end of stick lies at coordinate 0 and another end of stick is lies as coordinate L. So I need to perform the cut over these coordinates. And the input here in the question given that it is given with respect to one coordinate. So I assume that it is given with respect to this starting 0 coordinate, and I'll perform the cut. So since I need to find the minimum cost to perform all cuts in this given range, can I say that I'm looking here as optimal substructure, right? So what is the optimal substructure here? Optimal substructure is that minimum cost. So if you know that if our n is pretty smaller, that is of like less than 50, or even let's say if it's less than 500, then also it does work. And I am looking for optimal substructure minimum cost, it is pointing to somewhere dp, right? Yeah. So one thing I can conclude that I am looking for dp here. Now another thing comes in my mind, then which dp it is, right? So when we see that we are performing a cut at the particular segment, basically whenever we are performing a cut, we are removing a segment from the stick, right? And segment we already concluded is made of two coordinates. So can we say that this overall interval, that is 0 to L, can we say that this interval going to shrink, right? So in general, I can say that interval Ij will shrink when we perform a cut, right? Yeah. And therefore, if I look for it's to verify that it's by seeing that I can say that it is somewhere interval dp I need to utilize. But to verify that, I look for that whether the contiguous merge is happens or not. So if I look for that, if I let's say if I am looking at the smallest subproblem, the smallest subproblem in which like the last cut is made. After that, we are not performing any cut. So if we merge that, can we get the entire thing? Yeah. If I merge all the subproblems, I will get the entire state. So can we say that here the contiguous merge operation we are following, right? So since we are performing the contiguous merge and interval is a string, I can safely verify it is of interval DP. And even the like constraint is of n is telling and optimal substructure is telling. And basically interval shrinking is pointing toward interval DP only. Okay. Now, fine, we verify that this is an interval DP. Now comes in my mind that what interval DP it is then. We know that interval DP can be of many type like MCM combination type or your elimination pivot type, or it could be like somewhere we performing at the operation at the optimal endpoint selection, right? Or it can be a palindromic modification. So there are basically these four type of interval DP we look for. So we need to verify that which interval DP category it lies. To verify that, what we look for is that let's say that whenever we are performing a cut, let's see that what we are saying that whenever we are performing the cut, let's say I'm chop this portion out. Is this portion when we are performing the cut for this portion, is this portion is get eliminated? No, right? This portion is not get eliminated. So can we say that it is like the somewhere like I need to combine this? Yeah, I need to combine this. Okay, when we perform the cut for this, I need to combine this portion. So since I need to combine this portion, I can safely verify that this is the interval DP somewhere of type like, can we say that matrix chain multiplication MCM or combination type interval DP, right? Yeah, it is of somewhere matrix chain multiplication combination type interval DP. Fine. So these are the things I got to know from the question. Now look at the state. What state could be here? If I look for the state here, then it might be now obvious, right? Because it's interval GP, I need to track two pointers to both the end of the interval. So it would be DP as a 2D state, right? And I need to look for the minimum cost. So minimum cost to perform all cut in range IZ. Can we say that? Yeah. That is a basic interval DP here. Basically the basic state minimum cost to perform all cut in range IZ. Fine. Now, if I look for the transition state, so what could be the transition state here? So, since look at the one more thing, guys. Transition state, we look for all the split search point whenever we cut, as we know that in interval DP, if it is of MCM combination type, I choose the split search point. So I will iterate over all split search point K. And since it is of MCM combination type, so this split search point K will lie in the range IJ minus 1. Why so? Because in general what happened that if it is of not a like split search point K can be like in the range IJ if it of elimination or pivot type, whenever we write the state there, what happened that we like whenever we write this is of somewhere go to K plus 1. Okay, so if it go to K plus 1 and in that case the in the elimination pivot type what we happen, the state will get out of bound if I choose the say here. Yeah, like basically in elimination type, if I choose I to Z range, that will be safer. That does not go out of bound. But if I choose the MCM combination type, then it might possibility like here. Let's write only. Okay, what could be the state? We iterate over all the K, all the split search point K, and we take the minimum of all because I look for minimum of all. So it is of left subproblem. Yeah. Then right subproblem. Yeah. And basically cost, whatever the cost we look for. Cost to perform, the current cost to perform cut at the coordinate IZ, because we are looking for, we already found the smaller coordinates. Now we're looking for the current coordinate. So if I look for the left subproblem, then it will somewhere like dp ik, because it goes to the interval length I to k, right? And yeah, because start from it, basically what happened is I taken the interval this I to j minus 1, and I performed a cut somewhere at k here. Okay, yeah. So k lying in this coordinate I to j minus 1, that's what is it. The split search point lying in the range I j minus 1, and I perform the cut. So one segment, the left sub problem is lying in I to k, and another is of k to j minus 1. So if I just add it, it should be k to j minus 1. But this is the twist, guys. Why I not chosen it as j minus 1? Here it is a coordinate, right? So it can be shared, right? Yeah. But what if it is a real item? If it is a real item, I cannot share it, right? Yeah. If I share it, then it's not possible, right? If it's a real item, I only share with one of it. So in that case, I will look for k plus 1. Okay. Yeah. I'll look for k plus 1. Right. Exactly. But since it's not a real item, I'm looking for, I can share this. That's why I put it as k is a minus 1. And since if it's a real item, I look for k plus 1. So I cannot take it as j, because when I iterate over k, that in the length j minus 1, it will go out of bound here. That's why in general, in MCM combination type, k lies in the range I to j minus 1, and that is a safe one. Okay, yeah. And here, due to sharing, it starts with k. Okay, and whatever the cost we look for, the cost of IJ to perform the operation, in the question it is given that whatever the previous length, okay, yeah. So what could be the previous length, guys? We know that we are given with a coordinate that is come from this array. Okay, so whatever this array, let's say AI, this is the coordinate is given, and AJ minus 1. So can you say that the cost is nothing but this coordinate difference? Exactly. The cost is basically our coordinate difference. So just simply I will perform the whatever this coordinate is a minus 1 minus ai. This will give me the cost, right? That is basically the length before cut. Okay, yeah. So this is the transition state. Okay, now one more thing, guys. I would like to say that, or if you observe it, since it is interval dp, and if I observe this cost, okay, look at this cost here. Okay, just look at this cost. Does it depend on space subsequent k? No, right? Yeah. So if you are aware of, let's talk about on the next space. Okay. So if you are aware of, in the like what do you say, MCM combination type interval DP, I can optimize the, in general MCM combination type interval DP will take O of n cube time complexity, right? Yeah. Basically to track, iterate over all the length and starting index, and then choosing the pivot, basically the whatever the like a split search point we're taking that is lying in the worst case end. So overall it goes to O of n cube. So if I need to optimize, there is a trick that will cause the optimization. Let's say here the our n is given is of like lesser than 50, right? But what if n is not 50 and it is 3000? Can I go for O of n cube solution? No, right? It will cost me TLE, right? It will cross the barrier of 1.8, 10 to the power 8, right? So to optimize this, what we do, we have a technique that is known as Knuth-Yao optimization. What it does, guys, it combine like whenever we use MCM combination, it usually applicable to MCM combination type interval DP only. So it will optimize the O of n cube solution to O of n square solution. Okay, yeah. And the thing is that to do that, two conditions we need to satisfy. One is our, and that condition will be applicable on a cost function. Okay, so cost function should must satisfy our two conditions. One is your monotonicity, right? It could be monotone. And another is our quadrangle inequality. Okay. So what is the quadrangle inequality, guys? Basically, we are given with four coordinates A, B, C, D, where A is lesser than equal to B, is lesser than C, is lesser than D. And if I look for the cost, okay, if I look for the cost for AC and plus cost for BD, that should be lesser than equal to cost of AB, okay, and plus cost of BC. If this gets satisfied, I can say that the quadrangle inequality gets satisfied. And if quadrangle inequality gets satisfied, I have checked the condition to perform the Knuth-Yao optimization. Okay. So look at this coordinate. Okay. If I look here, the cost, what is the cost here? Okay. So basically the cost here is the length, right? Whatever the coordinate given, right? Basically nums j, let's say, minus nums I, yeah, where the nums I representing the coordinate at for index I in the array, right? So it does not depend on any other. It does only depend on the end of the state, like for a DPI, or basically for interval I, it only depends on endpoint of interval. Can we say that? Exactly. Since depends only on ends point of interval, I can safely perform if I put it here. I will able to satisfy this. Can we say that? Yeah. If I just put it here, just put it for the point AC. So it somewhere goes for nums C minus nums A. Right. Let's just put it fine. Right. Num C minus num C. Right. Then if I put for the coordinate BD, it is basically nums D minus nums A. Right. Yeah. And that should be lesser than equal to, if I look for coordinate AB, then it is nums B minus nums A. And for BC, it is again, right? Not BC, guys. It is basically here the first thing is stated ED and then BC. So it is basically nums B minus nums A. And basically nums, what do you say? C minus nums B. So if I just rearrange a bit, then I get that I have a nums C. Yeah, nums C plus nums D. Right. Yeah. Minus of nums A. Okay. And here, look at this. Look at this. I mistaken it. This should be B. Yeah. So what we'll look for here, minus of nums B. This should be actually equal. Okay, that is equal to nums C. Yeah, it's both coming out as equal. So yeah, just writing it, nums A minus nums B. So yeah, we can prove that whenever it depends on endpoint interval IZ cost function and no other thing is involved, I can safely say that quadrangle inequality gets satisfied. So since the quadrangle inequality gets satisfied and monotonicity, they given that the coordinates are given in the like increasing order. So basically this cost function should also be monotonic, right? Yeah. So monotonicity is also checked. Even if it's not given, if I just whatever the array given, if I just sort a bit, I will check the condition of monotonicity. So ultimately, like basically, we left out with this only quadrangle inequality. Are we checking this or not? So that is a usual trick, guys. That we'll just check that whether the cost function will depend on the outer endpoint of the interval. If it just depends on this, quadrangle inequality usually found. So I do not need to perform these, or I do not need to check this, right? So basically, I just check it and I say that yeah, Knuth-Yao optimization is applicable. So here also, Knuth-Yao optimization is applicable, right? So now it's just a simple implementation of it. So let's come to the implementation of it. Let's take my template. Yeah. And I need to change a bit here because we are given with the length, right? And it's not a usual test case. So I need to change according to the question. Let's wait a bit. So what we given is that we are given with the L, right? Yeah. I cannot take the input L because it might possible I run out of input. So I'll take it in this in the while loop because I need to take a multiple inputs here. And when the L is not equal to 0, the moment it becomes 0, I'll say that yeah, this is the one what we say, guys. We'll end the test case. Test cases get end. So that's what we define the condition. And then we'll just call our function. And in this function, guys, because I need to give the L, so I'll just must declare the L here. Yeah. Now let me take the inputs here, that is n. Basically, number of what do you call cuts we need to perform. Okay, the coordinates were given, right? Yeah. Now let's take the array that representing the coordinates. So let's just do that. Okay, so I'm just taking the input of the coordinates that is represented as the elements of the array. So that is fine. Right. Now, guys, it is fine. We're given with the coordinates. Okay, guys, so if I look at here, in the question, basically, this Ci is lying between 0 to L. Okay, so basically what I'm saying that whatever the coordinate that is lying between 0 to L, right? 0 and L is not included. And if I look at our cost function, it require me this coordinate, right? Can we say that? So let's say that if I am performing an operation at the interval 0 to let's say certain x, then to get the cost, I need 0, right? And to need, since I need 0, can we say that I should must include 0 in the array so that whenever I perform this ESA 1 or basically ESA minus 1 minus of AI, I should able to get this cost. Yeah, I should not get any garbage. Yeah, I should must have 0 available, right? So to like solve or resolve this, I will add the endpoint 0 and n in this container A. So for that, I need another container that take all the values of this A. Now I'm adding the endpoint, basically 0. Okay. And the other end. What is the other end, guys? That is the length. That is the length of the interval, right? Basically length of the stick, right? And that is our end, right? That's what we're taken, right? That's what we're given. That's the length of stick, right? So we'll just adding that, okay? And now I'll add all the values, coordinate at which I need to perform cut, right? I cannot perform cut at the outer end. I have always performed cut within it so that our like stick it cut in two parts, else it will remain at one part. Okay, so that's why I'm just adding the coordinates that I need to look for, and that is your AI, right? Yeah, so it's fine. If I just debug it, and one more thing, guys, I need to sort it. Why so? Because I look for monotonicity check, right? To perform the cost, I am performing it in a sequence. I cannot perform the cost at different end, else it might possible I am doing 25 minus 50 and we're getting a wrong answer. That could not be a possible one. So I'll always perform in a sorted manner, in a monotonic manner, right? That's why I basically sorting it. So if I just debug the B here and see what we get. So if I look for it, yeah, I'll get all the coordinates except 0 and the length or the last one, the whatever the end point, two ends point of the stick. This is the coordinate I need to perform the cuts, right? Yeah, fine. Now I come to the now like what I need to find. I just need to find the state here, and that is DPIZ that we already talked, that's representing the minimum cost to perform all cut in range IZ. So if I allocate it, it will be somewhere like I allocate in the container. Yeah, representing DP. But size of it will be what? So size of it will be like basically storing all the coordinates, right? and all the coordinates is there in the container B. So to represent all the coordinates, because I will go for all the coordinate either which we like whatever the coordinate it is, it will go for all coordinates, right? Yeah. J will also go for all coordinates. The total coordinate size it will go, and that's why we go for give the size as all the coordinates. And what we do, guys? We initialize what we initialize. Since I need to find the minimum cost, right? So what would be the save value for minimum? 1 is 17 infinite we use. Save value for minimum we initialize as 1 is 17. Okay, yeah, and that's why this is get initialized to 1 is 17, right? Now as we already talked about, like I need to use the O of NQ interval DP. So if I just use the O of NQ interval DP, that is of MCM combination type. Can we say it? Yeah, that is of MCM combination type. So what we do in this, I'll iterate over all possible interval length. But before that, let's initialize the base cases here. What could be possible? Like base case could be of length 0. Why length 0? If the interval is like I, something like this, if the segment is like this, just 1 point. Is it a segment? No, right? Not even a segment, right? So what would be the cost to like cut? 0, which we cannot perform any cut. That's why for that type of it, let's just initialize to 0. Okay, yeah. So dpi will be your 0. Fine. Now we are looking for another base case could be that yeah, this is not a proper base case, right? Because another base case also, like if I have one segment, okay, basically I can say that just one I and I plus 1. Okay, segment is of 2 length. Okay, segment is of not 2 length. Segment is between just 2 coordinates. Okay, just a coordinate like 4 and 5. Look at this. Can I perform cut in middle of it? No, right? There's not a single coordinate that can be resolved. I cannot perform the cut as 4 by half, right? So for that, also, since I cannot have a segment of length lesser than 1, the cost to perform cut for length 1 segment should be 0, right? That's why I can say that I'll iterate over m minus 1. Whatever the segment is of size 1, cost to perform cut will be 0. That's it. If I look for O of NQ interval DP, what we do is we'll iterate over all possible interval length. Okay? Yeah. We iterate over all possible interval length. So what could be the interval length we can iterate? Or what could be the possible interval length that is possible? Since I have, like, this is the m coordinate, the minimum length of interval should be obviously 0 already taken and 1 is already taken. So the possible interval length become 2, right? And the maximum will be like m coordinate will form maximum length of interval m minus 1. Yeah, because it will form the maximum segment of size m minus 1. Or if I take each segment of size 1, so m coordinate will able to form, can I say that m, or basically m length? Yeah, yeah, I'm not saying that the interval should be of length 1 only. Basically I have m coordinates. So if I just join all the coordinates, look at this. If I just join all the coordinates, this will be one segment 0, 25, 25, 50, 50, 75, 75, 100. So total number of like elements would be, total number of segments will be our m minus 1. Okay, so basically m coordinates will form the maximum segment m minus 1. So what could be the possible length of interval we can iterate? That is of 2 to m minus 1. That is our possible length of interval. So iterating over all possible length of interval. Okay, yeah. And now what we look for, another thing is that we iterate to calculate the state dpi, we iterate over all possible starting indices. Now look at this, guys. If I have a length, okay, if I have a length m minus 1, what could be the starting indices? It could be 0, one is it included or not? No. Why so? Look at this. If I have the length as m minus 1, then total I have to take m coordinates, right? The total we take m coordinates. So 0 is a 1 coordinate, and 1 to m minus 1 is another coordinates. So total m coordinates included, right? Yeah. Similarly, if I have a length, let's say m minus 2, then it will go for like 0. And is a 2 included? No, right? It will one of the segment could be of 0 to index up to index m minus 2, right? Another is of segment of 1 to m minus 1. It will take total m minus 1 coordinates, right? So I can say that this is 0 to 2 is the generic one, like 2 is not included. This is a generic starting indices. 0 and 1 is the starting indices if the length is our m minus 2. So for any general length, let's say, for any general length, what could be my starting indices? Huh? That will be, can I say that that is 0? Can I say that it is nothing but m minus, what do you say? M minus what? Length? Yeah, it is m minus length only. Look at this. If I put m minus 2 here, I'll get 0 to 2, right? And this is not included, obviously. If I put m minus 1 here, it will get me 1. So this is the generic starting indices. So we got the generic starting indices for all the intervals. So iterating over all the starting indices. Okay. Now, if I take the other end, if I take the other end of starting indices, so that is your I, and total how many points, like let's say if I'm looking for the length is length, so I need to add like how many elements. If I have the like a start is 0, right? Exactly. Whatever the I is our start, what will be total element, guys? If I have the length minus 1 coordinates, and I bound to have like what are you saying, right? If the length is of length, right? Yes, length is of length. Uh, then total the point or total number of points should be length plus 1, right? So one element is here. This I can simply say that I need to add here length only, not length minus 1. Why so? In general, we add length minus 1. Why? Because here you can see that two coordinates is forming one of the elements. So when I'm saying the length is of length, then one of the starting indices is 0. After that, how many indices will be there of the element? Basically, a coordinate here. That is of total length coordinate next will be there. So that's what it is. If you look at the last indices of the range Ij, that is of I plus length. That is what added here. Now we know that we choose a split search point, right? So if I look for the split search point, I'm not initially optimizing it. Okay, so I already told you the split search point will lie in the range IC minus 1. Fine. But there is a catch here. If I just use directly IJ minus 1, it might possible because I have added a 0. I am performing the operation at 0 that I don't want, right? Yeah. So to extrapolate, basically to not take this 0, I have always performed the basically cut at the inner points, right? Because basically look at this, guys. I have given, let's say, this interval I to z. Okay, yeah, this is the interval. This is I and z, and I need to split this in two parts. So obviously, I will put the cut somewhere in middle, either in this point or this point. So I just always lie in the middle part. Can we say that? So can I say that the actual split search point will always lie in the range I plus 1 and j minus 1, always the middle part. It cannot be the last one can be chosen because you want to divide the stick in two parts. If you choose this I, you cannot have like divide the stick in two parts. This will be of same stick only. that could not be chosen at a split search point, right? So iterating over all split search point, that is in the range I plus 1 to j minus 1 plus plus. If I calculate the current state, what is the current state, guys? Okay, that is your what do you call left subproblem. What is a left subproblem? That is of interval length ik that we already calculated. Then right subproblem, and this like whatever the split search point that could be shared. So that is kz. Can we say that? Yeah. And whatever the cost, what is the cost is? That is of the coordinates, whatever the coordinates we are performing. So let's say the interval is of I is this coordinate, j is this. So I'll just subtract this and the cost will get added. Can we say, guys? Exactly. The cost will get simply added. Okay. So if I just take the minimum because I need to find the optimal state, optimal value for this state. So I'll just perform the minimum and I'll get the answer here for the current state. So what is our task, guys? Our task is to just like find the cost for the last one, like in the complete interval. What is the complete interval? The complete interval is of length 0 to m minus 1. Like complete interval is of length m. Total m element is there, right? So I need to find the like what is the cost to merge all the like to perform all cuts in this interval length, whatever it is, like 0 to m minus 1, right? Yeah. So that's what it is. I just need to print the what you say dp 0 m minus 1. This is representing the cost. Yeah. Can we say this? Exactly. So if I just check for it, this is am I getting this values or not? So yeah, you can see that this is the value we can get it, and we just have to make sure this output format is there. So just look for it. Okay. Yeah. And another thing is that, yeah, fine. Okay. I'm just adding this output format according to the question. Yeah. So here we go, I guess. Yeah. That is the PC here. So this is one of the implementation, and that is a generic implementation of interval DP. Fine, nothing complex, nothing much here. But I am talking about the optimization of that. Okay, I can implement it using memoization technique also. If I just implement it using memoization technique, then I don't need to even track this, the length and this I. Okay, I just need to use this split search point k. So let's implement it using memoization technique also for a bit. Okay, so let's just comment it this and implement it using memoization technique. Then we'll get then we come to the last one. That is your Knuth-Yao optimization that will solve this problem in the O of n square. Memoization technique will also take O of n cube only, and plus the stack cost extra. Yeah, so that is fine. But the advantage I already talked, the memoization advantage is that I do not need to keep track of this length and this whatever the interval starting indices. Okay, that and because this IJ already tackled, right? So overall, like I do not need to worry. It already traveled all the length that I need to find, right? Yeah. So that's advantage of it. So let's just write the memoization. For that, before that, I need to initialize the memo table. So let's take the memo. Okay. And we are initializing it to -1. Basically, it states that state is not known. Total m elements is there. Okay. And if I calculate the just the particular state, so let's just calculate it. Okay. Yeah. That's it. And I need to give the what I need to give. I need to give the memo table here. Okay. Yeah. And what another thing I need to give? Uh, Array. It might possible I need, right, in finding the cost. So I need the coordinates so that I can take the cost or I can find the cost by finding the length of it. Right. I can say that this Ij is only the one that is the driving force that is responsible for shrinking the interval. And this too is just the static memory array. Okay. Yeah. Can we say that? Yeah, that is the only thing we need to look for. If I look for the base case here, like the first base case, if I just check the bounds here, so it might possible like if I is becoming greater than Z, then we go out of bound, right? So we'll just return the neutral failure. And what could be the neutral failure? That could be the safe value here, right? And what could be the safe value for minimum? That is 117. I choose infinite value, right? So that's what I have written. Another base case will be success check, whether basically driver, whatever the driver is ISA, it meet the condition, okay, that we're looking for. Basically, what could be the success check here? This, right? The length of, we have reached to the smallest subproblem. The length of interval become 1, right? Or it could be 0, for the case. But at the 1 only, I will just end it, right? So I can say that another base case should be that if j minus I is lesser than equal to 1. If it is lesser than equal to 1, then what is the cost? 0. That's what we added. Like no addition in the cost, right? We already talked that if the length of segment is 1, we cannot split it, we cannot cut it. So the cost to cut will be 0, so that we cannot perform cut. In this bound check, I added 1 is 17 so that when I take the minimum, it does not affect overall minimum, right? That's why this get performed, okay? Here failure check like knapsack cannot be done. It's not possible that it ran out of element, right? Yeah, because here always the element is available. And yeah, that's a one thing. And here the pruning check. Yeah, we pruning check is also no need to do. We can directly optimize it to Knuth-Yao 2 of n square. So in general, no pruning check need to perform. And the next check comes that is the memoization cast check. So memoization cast check would be that if the state is known, no need to calculate again. So it's a general, just return the state. If you know the state, no need to calculate, just return the state, and that's it. Fine. Now, if I iterate over the option loop, what are the options we have? The split search point basically, because I and J is already sorted. So the split search point, I already told you, it lie in the middle point. So it will lie in the range I plus 1 and J minus 1. So what we do, guys, we'll just iterate over all the range of the split search point, that is I plus 1. And what do you say? Basically, C minus 1 smaller than that, then I plus plus. Now I need to calculate the left sub problem. Basically, if I calculate the left sub problem, then what it comes out? Ik interval I to k, right? Yeah. And just giving the memo in it. That's not a problem. And if I calculate the right sub problem, same only, I'm just repeating the conversion to the memoization. So I need to take the k because I can share the like coordinates. I can already told you in the tabulation technique. So that is k. And what is the endpoint of it? That is say, right? Yeah. So another interval 1 is your I to k. This is I to k. And this can be said the k to z, right? And that's it. And the next thing I'm left out with is in the state, I need to look for cost. And what is cost, guys? That is nothing but Pj minus Ki. The length of the stick we are performing, the length of the segment we are cutting. So since I need to find the overall minimum, so what will be the minimum value? That is 1 is 17. That is the safe value we take. So that when I take a minima, it does not affect the overall minima. So minimum will be minimum and whatever our current state. What is current state, guys? Just the addition of all, right? Left subproblem, can we say, plus right subproblem, and plus the cost. So it is the addition of all. So I need to find the minimum of minima and current state so that I will calculate the optimal state for DP IZ. Now I'll just cast it and return. That's a simple, like or useless thing in the memoization. You can say not a useless, very like it saves the memory, else you get recursion. Memoization will get converted in recursion and the stack will just go overflowing. So I'll just cast it and I'll just return. Okay, fine. So this is the generic like implementation by memoization or simple implementation by memoization. So what I need to do, guys, I just need to calculate the minimum cost. Now what it could be, it will be lie in the interval 0 to m minus 1 and m memo we pass, and be cautious. I cannot pass the initial array A. Why so? Because if I pass the initial array A, I have not included this outer bound. So I must pass the interval B here. That is a mistake usually people do. So I must pass that. Yeah. And now we just need to print it. This I already basically, what is it? This I have commented it in past. I just get uncommented. Yeah, fine. So I just basically need to print the minimum cost. Okay. And what it could be? Just the minimum, right? Let's just go for it. I expect the answer, right? Runtime error. Runtime error. Why? Look at this. This is the error. Huh? It's A plus plus. It is, so it should be K plus plus, right? Should I incrementing the whole? Yeah, it's fine. Yeah, now it's passing, right? So this is the way we can implement using the memoization technique. Advantage we already talked. We don't need to iterate over the length. We don't need to keep track of it, and we don't need to keep track of starting and ending indices. It automatically get like implemented because here we don't need to search for the topological dependency. It does not calculate entire state. It will calculate only the state that matters. So the entire topological dependency we don't look for, and that's why we're able to get the answer, right? Yeah, and that is fine. So guys, if I come to the most optimal solution of it, that is of O of n square, and that will be optimized using Knuth-Yao optimization. Okay, yeah, and we already told you that Knuth-Yao optimization is valid here because it satisfies the monotonicity, and also here, what do you call the another condition of Knuth-Yao optimization, as we already talked, that is, what do we call here, quadrangle inequality. So it satisfies both. It satisfies the monotonicity and it satisfies the quadrangle inequality. So we can safely perform Knuth-Yao optimization here. So if I just do that, in Knuth-Yao optimization, two things I need to keep track of. One is your original state that will remain same. That's not a problem. Okay. Apart from this, I will keep track of what is the optimal K for a particular range I say. For each range, we should keep track of optimal K. And for that, I'll just use the container same only. Let's say the optimal K is represented by OPT for a range IJ, right? And I initialize. Initially, the optimal K will be what? What is the same value for it? The first value, let's say the smallest one, segment is of only one element, right? Zero. Zero basically means, yeah, I might choose here -1, but I can choose zero also. That's not a problem because it cannot be a split search point, right? So that could be our optimal key. So I'll just skip that is a safe value here, right? So that is the optimal key. We need to keep track of it. And in Knuth-Yao optimization, for every range I say, whatever the split search point k that usually taken, that lies in the range optimal ij minus 1. Okay, whenever we build the like tabulation only, we build like tabulation only. this optimal ij will always lies in this optimal ij minus 1 to optimal I plus 1 j. Okay, so since this slide is whenever instead what we did, guys, we don't iterate over the split stage point k. Instead, the starting point become optimal ij minus 1 and ending one become optimal I plus 1j. So we'll just iterate about this split search point here. But this is not a worst case, like it will not of often. It will a constant iteration. Somewhere up close to, that's why some okay, like some of the constant value. That's why I'll say that it's close to O of 1 only. And that's why I say that the overall complexity of O of n cube here get broken in O of n square. And that's why this optimization works, right? That is a part of it. Now the usual base case, it could be of length 0, in which like what do you say? That is the like I cannot merge simple like this. So cost will be becoming 0. But what would be the optimal index? In length 0, that index only, whatever the element that is, like if I have only I element, then what will be the split index I only? That will be you can take, right? Yeah, fine. But so just doing this. Okay, total we have m elements and initializing the base case VPII for length 0, that's 0. And split size point, the element only, fine. Okay. Now another thing is that if I look for length 1, if I look for length 1, then I already proved that at length 1 also in here, look at this. Length 1 also, there cannot be cut will be made because there cannot be any segment of length 0, right? Yeah, you cannot cut values like this because there cannot be a segment of, they cannot be split like 4 and 4 half. This must be an integer as per the coordinate here, right? So because of that, if that is the case, then I already say that the cost is 0, so that's just we calculate. But there is a thing here, one thing is there, that fine, my cost is 0, right? But what about the optimal split size point k? I can either take it as I, or I can take it as I plus 1. But my thing is that by default, we always choose I plus 1 because we are somewhere building the bottom up. So we'll go in the increasing order. So we'll try to always choose the right one. So that whenever we merge the two subproblem, let's say 4, 5, 6, so 5 will be get shared, or 5 will be the one that consider in the cut. So that's why we always choose the right, whatever the right boundary, that will be chosen as the optimal value of the split search point, right? Yeah. So now performing the general steps of interval DP, what we do in interval DP, guys, we iterate over all possible length of in these like intervals. So what it is, we already found earlier, that is the possible length of what you call intervals is 2 to m minus 1. 2 to m minus 1, yeah. And then the length plus plus. That's what we're doing. So look at this, guys. The possible length of interval is 2 to m minus 1. That's what we're doing. Fine. We already found it. Now we iterate over all possible starting indices that we already found when we have calculated this. That is 0 and m minus length. Yeah, starting in this lies in the range 0 to m minus length, where m minus length is not included. Fine. So I lesser than m minus length and I plus plus. Now, what is the other end of the, like, what is the other end of what? Other end of interval. That is nothing but I plus length. We already calculated earlier, right? Yeah. Now, if I look for the change here, the change here is the split search point k. Okay. Split search point k, we already say that it lies in the range ij minus 1 to I plus 1 z. And this loop is a constant only. So we able to convert O of n cube to O of n square. So we'll just writing it for the current interval. The split search point lies in the range I say minus 1 and up to I plus 1j, and we'll just increment it. So if I find this current state here, what is the current state? That is of the first one, let's say I to k, and then k to z. K can be shared because it is a boundary. If it's a real item, k cannot be shared, right? And plus the cost. And what is the cost here? The cost here is the basically your what you say bz minus of bi, right? That is the element we are taking, right? Yeah, that is the element we are taking. So that is the cost we calculate. Okay, we cannot take the ESA minus AI. The reason is that ESA is not the original coordinate because it is 0 and 100 is not included. To avoid that, we already have what we did. We already have added a coordinate initially, and that's why we are taking the BJ minus BI. Yeah. So that is a current step. Now, what we did is, fine, there could be one thing that I can just update the current state. But updating the current state will not lead me to the overall update of the key here, like optimizer, because we have not calculated this optimalizer. We are also building this optimalizer together with the DP, right? So what we do is, whenever we find the optimal state, means whenever our current state is lesser than the current state of DPIZ, then the one thing will be as usual, update the DPIZ. That's what we did. DPIZ will be your current state and it get updated, right? But another thing could be that the optimal k that we are looking for, that is not still updated. So I'm saying that I'm splitting at the index k. So we know that we by default we always check the right boundary at the optimal k. So in that case, for I to k, what will be the optimal boundary? That is k only, right? So that's why we choose here. We update the optimal I say that is equal to k. If I do that, we have basically calculated all the states that we learned, right? Guys, what I need to do now, I need to just print it. So that's what we do. We'll just print it because we already get the state. Print for the what is the cost in the range 0 to n minus 1. Just same as this. Like I expect correct answer. Oh, length is not declared. Let's just declare it. Now we expect the correct answer. Yeah. So safely pass, right? So you can say that fine, that's the implementation. Okay.